Welcome back to class. In this lesson, we'll use a work example to see how to calculate electrical energy in series and parallel circuit. Work example says two heaters A and B are in parallel across supply voltage Y. Heater A produces 500 kilocal in 200 minutes. A and B produces 1000 kilocal in 10 minutes. The resistance of A is 10 ohms. What is the resistance of B? Now, the first thing I want us to see is to envisage the parallel connection between eta A and eta B. So that here is a parallel connection between eta A. Let's tag this as our eta A and let's tag this as our eta B. And here is the voltage source Y. Now, since these resistors are connected in parallel, that shows that the voltage Y across A will be the same voltage Y across. Now, the heat energy dissipated on each of them or on each of the heating element will be given as V squared over R times T, where my V squared already we've been told is same thing as what? As Y. So I'll change that easily to Y squared over R times T. Now for the first voltage or for the first heating element A, we've been told that it has 500 kilocal. Now, so that my 500 will be the same thing as V squared over R. My R in this instance we told is 10 ohms times my T is 200 minutes times 60 seconds. Now to calculate my V squared from this will be given as 500 will cross multiply by 10 times 10 over 200 times 60. So that here is 6 here is 0 cancel 0. Then my these two zeros here obviously cancels these two zeros. So I'll be left with 5 over 12. Now I can assume that this is 5 over 12. Since I'm going to look for the resistance of B, I'll just leave this as V squared because I'll still use the same V squared in looking for the resistance. Now let's create another slide. Now since my V squared is equals to 5 over 12, now to calculate the heat around B is still the same V squared over R times T. And the heat around B, we were told the heat around B is 1000 kilocal will be the same thing as V squared, that's 5 over 12 times 1 over R, which is what we're looking for, times T, 10 minutes. It had a time of 10 minutes, that's 10 times 60. Now I can easily multiply so that I have my 1000 times 12 times R to be the same thing as 5 times 10 times 60. So that R now will be the same thing as 5 times 10 times 60 over 1000 times 12. 0 here cancels 0 here. 0 here cancels 0 here. 5 here is 1. 5 here is 2. 2 here is 1. 2 here is 3. 3 here is 1. Obviously 3 here is 4. So that R invariably is the same thing as 1 over 4 ohms. That's the same thing as 0.25 ohms. Now that's the first part of the question. The second part of the question wants me to find for the same heaters are connected in series across the voltage V, how much heat will be produced. Now since I have same heaters connected, that is this is my 10 ohms for the A. Now they are connected in series. We've gotten the B to be 0.25 ohms. And the voltage here, the square of this voltage, remember we're using the square of the voltage, we've gotten it to be 5 over 12. I want to leave these values this way. Now, I'll be saying that the total resistance here, R, will be the same thing as 10 plus 0.25. Now, my heat here, the heat that will be dissipated across all of them, still will come from V squared over R times T. This will be the same thing as V squared. My V squared is 5 over 12 times 1 over 10.25 times T. T is the same thing as 5 minutes. 5 times 60. We're converting to seconds. So that this will now be the same thing. For my calculator, this will be the same thing as 12.2 kilocal. That will be 12.2 kilocal. With this, I hope you understand how to calculate electrical energy in parallel and series circuit. Thank you for staying with us and see you in our next class.